Hello and welcome back. We're going to start a new unit here, and this is going to be um, chapter 4, and that's Inequalities and Applications. Okay, and so what we're going to do is we're going to talk about sections 4.1 and 4.2 today in this video, and it's going to deal with inequalities, intersections, unions, and compound inequalities. So kind of a lot of information here, but let's just kind of talk about a general scenario that you could find yourself in. Suppose that you're on a business trip and you're given a budget of $250. Okay, so that's the amount of money that you can spend on a rental car. Okay, and then, but there's some stipulations with the rental car. Okay, the rental car company charges $45 per day plus 10 cents per mile. Okay, and then if you need a rental car for 2 days, how many miles can you drive to stay within your budget? Okay, and so what this calls for is that, you have a budget. This is the maximum amount of money that you can spend on a rental car, okay? And so you need to figure out the number of miles that you can drive to not spend more than $250, okay? And that's what this means. So what we can say here is that this thing translates to what's called an inequality, because you can have as many miles as you want, a certain number of miles that will keep you under $250, okay? And so when we see something like that, like a range of values, we can say that the total rental car charge must be less than or equal to $250, okay? And so let's kind of think about that. What that's going to look like is this, that we have something that is less than or equal to $250, okay? And then, sometimes, we have this thing called a range of possible solutions. We're going to kind of talk about that today. Then we use what's called an inequality. Okay, so this is a symbol of inequality. We'll talk about it down here, but let's just kind of make something to set up this inequality here. And so what we're going to do is we're going to $45 per day, and we have that for 2 days. So I'm going to do this. I'm going to do 45 times 2, and then plus 10 cents, so 0.10 times x, and x is going to represent the number of miles, okay? And so, so that's what we've got, all right? Now let's talk about some vocabulary that we're going to use here for inequalities, okay? And so the first thing that we've got, this inequality is any sentence containing, these symbols: less than, greater than, less than or equal to, greater than or equal to, or not equal to. Okay, so that's what those mean. A solution means that any value for the variable that makes the inequality true is called a solution. Okay, solution set, the set of all possible solutions to an inequality. Interval notation is a way to write all of the solutions of an inequality in one variable. Interval notation uses parentheses and brackets, okay? An open interval means that the open interval a to b means a is less than or equal to less than x is also less than b. Closed means that you also contain the endpoints of that interval. Okay, a half open interval means that one side is, we include it and the other one we don't. So parentheses AB bracket means a is less than x is less than or equal to b. Okay, and the same on the other side. Okay, so we include a here, so it's equal to a, but we don't include b, so it's just strictly less than b. Okay, so let's go over here and look at some examples. Okay, and we want to translate each situation into an algebraic sentence with use of an inequality. So what I want to use here is part A. It says an elevator can hold no more than 2,000 pounds. Okay, so what I want to do for that is, for part A, an elevator can hold no more than 2,000 pounds. So I'm going to do x, and I'm going to do 2,000. Okay, and what I want to think about is that I can't exceed 2,000 pounds on an elevator. Okay, but we're going to have x be the number of pounds. Okay, number of pounds. Okay, and this is the maximum weight. All right. Now, if I want to say that I can't have no more than 2,000 pounds, means that I can include 2,000 pounds. I put this little line here, but then I have to think that all of the number of pounds, this needs to be smaller, okay? This is smaller, and this is big, okay? This is the max, all right? And so when my variable, the number of pounds, things that I don't know, needs to be smaller, means that I need to make my symbol like this, okay? And when I think of that, you know, a lot of people think that, you know, this is the Pac-Man. I like to think of this as the shark, okay? And the shark is going to eat the bigger, and here's my shark. Okay, the shark is going to eat the bigger number, okay? And that's how I think of that. So, all right, let's take a look at part B. Okay, let me do that over here. Part B is going to be you must spend at least $50 to receive the discount. Okay, so you have to spend, like if you're going to go buy something and it's like, hey, you get a discount if you spend more than this amount of money. Okay, and so that's what that means. At least $50 means that you need to spend more than $50. All right, so I'm going to put here, I'm going to put 50, I'm going to put X, okay, and then I'm going to put 50, okay. In the amount of money that you have to spend, it needs to be at least $50. So if you spend $50, okay, you're going to get the discount. So I'm going to put equal to, and that my value for X is going to be greater than $50, okay, and that's how I turn those algebraic sentences into, you know, an inequality. All right, so now let's take a look here. I want to talk to you guys about what we call translating set builder notation, interval notation, and graphing on a number line. So here's what I want to do. Okay, so I want to take this top part here, okay, and read that, and this says word form. So here are the different words that we can see, okay. We're going to translate them into symbols. So I'm going to write symbols, okay. We're going to put that into set builder notation, okay, to show you one way, and then we're going to show you that same thing in interval notation, and then we're going to show you the graph of that, okay. So let's take this. Let's take the word form is greater than, is more than, and must exceed. Okay, what I'm going to do is I'm going to put that this part, the symbol, is just greater than. Okay, and that's the translation that we see. Okay, if I were to put this into set builder notation, what I would say is like X is going to be greater than, say, 0. Okay, let me talk about that in interval notation here, but let me draw the graph here. And the graph, I'm going to put, draw a number line, put 0. Because we're strictly dealing with is greater than and not just equal to, what we're going to do is we're going to use a parenthesis here to graph, and we're going to graph to the right. Okay, and this is positive and this is negative because there's 0. All right, and so what I have, if I wanted to put that in interval notation, I would say that, you know, if we start at 0, we go to positive infinity. And how I read interval notation, that's read from left to right. All right, so let me do left to right. And this is where we start, and this is where we end. Okay, and so we're starting at 0. We don't include 0. Okay, we're strictly just greater than 0. And so we shade to the right of that the values of X that are, you know, that will make this true are values that are going to be larger than 0. Okay, but when we take from the graph to interval notation, we go from 0 to infinity, from the left to the right, and we don't stop. We just keep going because we are just larger than 0. Okay, now let's look at is less than. All right, and so everything's just going to be the opposite. All right, so we're going to go from, we're going to draw our inequality symbol like that. Okay, we're going to say that X is less than 0. Okay, so my values that will make this true are numbers that are going to be smaller than 0. Okay, and so what I've got here, let me draw the graph of this real quick. Okay, this is positive, this is negative, this here is 0, and we're less than, so we're going to put a parenthesis and we're going to shade to the left. Okay, and so that's going to give us, we're going to start at negative infinity and we're going to go to 0. Okay, parenthesis. All right, now let's talk about the other way around, or with this equal to. So is greater than or equal to is at least or no less than, then what we can say is that we're greater than or equal to. Okay, if we wanted to say that in set builder notation, I would say x is greater than or equal to 0. And so in interval, or let's draw the graph first, okay? And so here I've got my 0, here's positive, here's negative. What I would do is I would put this and put a bracket because we're including 0, and we're going to shade to the right, okay? And then what we have here is we're going to do that we start at 0, so I'm going to put a bracket at 0, and we're going to shade to positive infinity, but we can't ever stop at infinity, so we're just going to keep going, so we just never include that. We just always put the parenthesis around infinity. Okay, let's go the other way around, and let's do is less than or equal to. This is going to be x is less than or equal to 0. Let's draw this on a graph first, and let's put a 0 here, positive, negative, and then let's draw our bracket here and shade to the left. And then this is going to give me from negative infinity, so parenthesis negative infinity to 0, and then we include that with the bracket, okay? So let's kind of do this over here for A, B, and C. For A, okay, I want to do x is greater than 3, okay? So for A, if I wanted to graph it on a number line, let's do that first. That's kind of the easier thing for me. And let's put a 0 in here, and then let's just put the number 3 that we're dealing with, okay? And so what I know is that x is strictly greater than 3. So the numbers that are going to make this true are numbers like 4, 5, 6, 7, 8, and so on. And so that's where we're going to shade, okay? But since we're just, x is strictly greater than, we're going to use a parenthesis here, and we're going to shade to the right. Okay, so then I get to do my interval notation and say, all right, this interval, the solution set, goes from 3 to infinity. Okay, all three of these things are the same thing. Okay, this is my graph. Okay, and this is interval notation. Okay, and so let's look at part B here. Okay, part B says that x is less than or equal to 7. So let's draw our number line here. Let's put in a 0, okay, and then let's put in the number that we're dealing with, which is 7, okay? And so my values for x are going to be less than or equal to 7, okay? So I'm going to put a bracket, and I know that my numbers that are going to be smaller than 7 is what's going to be shaded, okay? So I'm going to come in here, draw in my bracket, and then shade to the left of that, okay? And so in interval notation, what I would do is I would say that this goes from negative infinity, comma, 7, and put a bracket there, okay? Okay, let's look at the last one, which is C, and this one's a little bit different, and mainly because the x value is on the right side, okay? And we can do that. It doesn't matter. And in this case, you know, I always revert back to, if you're kind of struggling with, you know, hey, which one's which, you know, what direction is it going? Does it have anything to do with the pointing? And yeah, it does, but I always go back to drawing the shark, okay? And the shark, that won't ever fail when you're doing this, okay? The shark will always eat the bigger number, okay? And that helps me say, okay, this side is big, this side is small, okay? It kind of just depends, all right? So, all right, so now let's take a look at that one, and let's do that real quick. So negative 1 is less than x. So let's draw a graph here real quick, okay? And let's put in a 0, and then let's put in a negative 1. Okay, and what I know is that because my shark is eating the bigger number, that means that my variable, what I'm looking for, needs to be small. Okay, this is small. This part is big. Okay, and so my solutions are going to be small, and small means we go to the left and we're negative. Okay, and so I'm just going to put a parenthesis here to signify that, and I'm going to shade to the left. Okay, so it is a little bit different, but you just kind of have to, you know, think about the shark. Which one's bigger? Which one's smaller? Where's my variable? That's where it needs to go, smaller or bigger. That's where you shade. Okay, in interval notation, this is going to look like negative infinity to negative 1 with a parenthesis, okay? And that's all we're doing. All right, let's take a look at the last part of this page, okay? And I want to talk about solving linear inequalities, okay? And so we solve inequalities the same way as solving equations, except when we multiply or divide by a negative number, we must flip the inequality. And we're wondering why that's the case, okay? Because you may have seen that before. Now let's think of some true statements when it comes to inequalities, okay? So a true statement, if I were to say an inequality, let's say that the number 1, that number is less than, say, 8, okay? That's a true statement. And you can say that the same way. You can say that 8 is larger than 1. Okay, you can say them both ways, all right? Now let's think of another like definite true statement. And let's say like -2 is less than 10. Okay, so the value of -2 is smaller than 10, all right? And so what I want to say is, okay, I can do a number of things to this. If I add 3 on the right side and 3 on the left side, okay, then I'm going to get the inequality, say, what is that? +1 is going to be less than 13. This is still true, okay? If we were to, change that up and say, -2 is less than 10, if we were to, like, say, subtract 3 from both sides, then we would get, -5 is less than 7, and this is still true, okay? Now, let's take a look here, and let's think about something, all right? If I take that same inequality, -2 is less than 10, okay, if I were to, like, multiply this by 2 on both sides, I would get, -4 is less than 20. Okay, this is still true, all right? But if I were to take, say, -2 is less than 10 and divide by 2, okay, then I'm going to get, say, -1 is less than 5. This is still true, all right? So what I'm doing is I'm doing all the different operations you can do, okay, when you're doing algebra. So you can still, if you add to both sides, you're going to get a true statement, okay? If you subtract on both sides, you're going to get a true statement, okay? If you multiply by a positive number, you're going to get a true statement. If you multiply by or divide by a positive number, you're also going to get a true statement. However, okay, and let's look at this, all right? If I take -2 is less than 10, and I divide both sides by -2, think about what happens. I'm going to get +1 is less than -5. This is false, okay? And so there's something that happens here when we, do this, when we divide by a negative or multiply by a negative. If you don't flip the inequality sign, you're going to have a false statement. In order to get a true statement, okay, so my true statement would be if I were to have 1 is greater than -5. Okay, so we always must flip, okay, must flip if we divide or multiply by a negative number, okay? And so, and that's what we're doing, okay? So that's a trick, okay? All right, so let's take a look at these examples here. And what I'm going to do is I'm going to solve these. I'm going to write my answer in interval notation, so like I see up here, okay? And so let's take a look at part A. And let me write this down here because I don't have much room. Part A, I'm going to take 5x plus 6 is greater than or equal to 2x and then -2. All right, so to solve this equation, I'm going to do anything I would normally do to solve this equation, okay? And what I'm going to do first is I'm going to combine my x's, and so I'm going to subtract both sides by 2x, okay, here and here, all right? And then I'm going to get that this is 3x, okay, plus 6 is greater than or equal to -2. I'm going to go ahead and subtract my 6 over here and here, okay, and I'm going to get that 3x is greater than or equal to -8, all right? Last thing I'm going to do is I'm going to divide both sides by +3, and since I'm divided by a positive, I don't have to change anything. And so then I get that x is greater than or equal to negative 8/3. Okay, and so what I want to think about, in order to put this in an interval notation, usually what I do is I'm going to graph it, all right, and I'm going to do a simple little graph here. I'm going to put a 0. Negative 8/3 is to the left, so negative 8/3. All right, and we are greater than, okay, the shark is eating the bigger number, so because it's big, x is big, we're going to go to the right, okay? And so we're also going to include that here and here. Okay, that's my graph. So then an interval notation is easy for me to read, and I'm just going to go from left to right, negative 8/3 with a bracket, comma, 1, or infinity, and that's it, and that's my answer, okay? And that's how we want it. All right, let's look at B. All right, so for part B, we've got 1 minus, so 1 minus the quantity 2x plus 8 is going to be less than the quantity 9 plus x and then minus 4x, okay? All right, so the first thing I want to do here is distribute my negative, okay, into here, and so I'm going to get 1 minus 2x minus 8 is going to be less than, and the parentheses here don't really matter because I have a positive sign out here. So if I just have a positive sign, then I don't have to group this, okay, and I'm just going to write it as 9 plus x and then minus 4x. All right, and so then what I've got, let's combine our like terms here. I've got 1 minus 8. That's going to give me negative 7, okay, and then minus 2x. This is going to be less than 9, and then if I take x minus 4x, that's going to give me minus 3x. Now for the next step, guys, when I do these, I strategically do them so that I always get a positive coefficient in front of the x. And so if I'm going to solve this, what I'm going to do is I'm going to go ahead and then just add a 3x to both sides. Okay, so add 3x, and then what I'm going to get as a result is negative 7, negative 2x plus 3x is just going to give me a positive x, just 1x, and that's going to be less than 9. Okay, now the next step that I'm going to do is I'm going to then add 7 to both sides, all right? And so then as a result, I'm going to get that x is less than 16. Okay, now if I wanted to graph that, I would just draw a little number line here, put my 0 in, put my 16 in, and say that my values for x are going to be smaller, okay? 16 is bigger. The shark is eating the bigger number, okay, so x is smaller than 16. Okay, now it's just going to be less than, so I'm just going to draw a parenthesis and then shade to the left, and that's going to help me write my my interval notation, which is going to go from negative infinity to positive 16 in parentheses, okay? Now, guys, I do apologize for the lack of space. Make sure that you're trying to, stay within your means here, so write small. I apologize. All right, next page. Okay, on this page, we want to talk about compound inequalities, okay? And this is just more than one inequality, okay? So we have more than one inequality, okay? And we have two different kinds. We have a disjunction, okay, which is and we think of this as the intersection. Okay, and then we have a disjunction, which is or, and that means a union, okay, of two inequalities, okay. A conjunction, meaning intersection, is where they have both. Now, the easy way for me to figure out if we have an or situation or a disjunction for union is using the signal for union, which is U. So to kind of think about this, is using this example, okay, which says, use inequalities to translate the situation into an algebraic sentence. my target weight loss is between 20 and 30 pounds. So what I would want to write here is X, and this is going to be target weight loss. All right. Weight loss. And we want that to be between 20 and 30 pounds, which means that my value for X needs to be any number in between those two. So it would need to be less than 30, but at the same time, it would also need to be greater than 20. Okay, and so X is going to be greater than 20, but less than 30. So greater than 20, but less than 30. Okay, this involves two different things. Okay, and so what we're going to do is we're going to graph this, and we're going to write it in interval notation. All right, so let's do that real quick. Okay, if I were to graph this, I would say, here's 0. The numbers that I'm dealing with are 20 and 30. Okay, and my values for X are going to be between them. So we're going to be greater than 20, but we're going to be less than 30. Okay, and so if we were to write this in interval notation, we would say that this goes from 20 to 30 and all the numbers in between. Okay, and so hopefully this makes a little bit more sense of like what we're doing when it comes to talking about interval notation and graphic notation, and then this is set builder notation. So all three of these things mean the same thing. All right. Now, in order to do some of these problems, some of them are pretty easy, like part A. Like this one's pretty easy. All right, let's just draw a number line here and make the solution. Okay, and this is going to be, I'm going to put my 0 in, I'm going to put -2, and then I'm going to put 5. Okay, and my values for X are going to be larger than -2. So parenthesis at -2, all right, and we're going to shade, but we're also going to be less than or equal to 5. Okay, so a bracket here, and then we're going to shade it to that bracket. All right, in interval notation, we would write this as -2, comma, 5 with a bracket. All right, and make it look just like that. Okay, all three of those things mean the same thing. All right, let's take a look at B. Now, this is where it gets a little bit trickier. Okay, I'm going to graph X is greater than -2 and X is less than or equal to 5 on separate graphs. Okay, so let's do this one in red. Okay, and I'm going to put my 0 here, I'm going to put my -2 here, and 5. And for this inequality, I would write X is greater than -2. So I'm going to put a parenthesis at -2 and shade to the right, okay, because we're greater than -2. Now I'm going to do this other one in blue, okay, and when I do this, I'm going to put my 0 in the same spot, -2 over here, and then a 5, okay, and so I'm going to be X is less than or equal to 5, so I include 5, and I'm less than or equal to. Because I'm using the word and, okay, and this means intersection. So the question is where do I have, if I were to combine both of these graphs into one, where would I have common points? And that would be when you're less than 5, but at the same time greater than -2, okay? So let's draw the compound inequality. And this is going to be the same thing we had on the last one. Put my 0 here, put my -2 here, put my 5 here, and I'm going to put a parenthesis. And that's going to be at -2. Okay, we're going to put a bracket at 5. Okay, and then we're going to shade in between. Okay, and notice how this intersection is the same as this intersection. Okay, and that's usually the case with intersections, but not always. Okay, so it's important that, if it's given in this notation, it's pretty easy to graph. But when you have the word in between, that's when it gets tricky. All right, so let's look at part C. Okay, and this is a different one. This is a union. Okay, so for this one, let's graph X is less than -2. All right, so I'm going to do this here. All right, so let me put in 0, -2, and 5. Okay, just like we had. And X is going to be less than -2, so we're going to be smaller than -2. Okay, we're not going to include it, put a parenthesis there. Okay, and then let's graph x is greater than or equal to 5, all right? And so on this one, same thing, 0, -2, 5. And for this one, we're going to shade to the right, okay? We include 5, and the values for x are going to be larger than 5, so we shade here. Now, because this is an OR problem, okay, because we're combining these two with OR, this is a union. And when I think of union, I like to think of the word marriage, okay? It means that the guy's going to take all of his stuff, the girl's going to take all of her stuff, and they're going to put it together into one household, okay? And that's the third graph, okay? Let's put our same numbers down, 0, 5, and -2. And this means that we're going to put everything onto the same graph. So from -2, we're going to graph this part. And then for 5 and above, we're going to graph this part. And that's my answer. Okay, if we wanted to put this into interval notation, then what I would do is I would do this. I would say, you know, that we have from -infinity to -2, all right, that part of the graph. And then we're going to have the part of the graph leave some space, and this goes from 5 to +infinity. Okay, and in between the two, we're going to put a U for union. Okay, so this would be my interval notation, and this other part would be my graph. All right. Okay, now let's do part D. Okay, part D is all the way down here. All right, and we're going to do x is less than or equal to 3, and x is greater than 0. So let's do this one in red. I'm going to do 0 and -3 is over here. Okay, so on this, all my values for x are going to be less than or equal to -3. So I'm going to put my bracket down, and we're going to shade to the left of -3. Okay, now on the other part, you know, let's do x is less than 0, and let's graph this one. Okay, and so here's 0, here's -3, and since we're just less than 0, what we're going to do is draw a bracket here, and we're going to shade to the left because my values of x are smaller than 0. Okay, so now the question is what's our final answer? Okay, so how do we combine them? So right now we're doing the intersection. Okay, and on this type of problem, all right, when you've got graphs going in the same direction, you want to say, okay, where do I have common points? Okay, this graph is less than or equal to 3. This graph includes that part, but this graph up here does not include these points here. So we have to do the intersection. Where do they both exist? And so when I draw my last one, okay, put your 0 down, put your -3 down, we're just going to continue and just graph this part, okay? And then if I wanted to put that into interval notation, what I would say is I go from -infinity to -3, and we put a bracket around that, parenthesis around that, okay? All right, let's take a look at part E. And this is a union because of OR, all right? So that's one of the first things I look at. OR means union, okay? And so let's do the first one. Let's do x is greater than 5. And so let me do this. All right, whoops. Do that in red, okay? So let's put our 0 down, and let's put 5. And then the other number we're dealing with is 10, so I'm going to put that on there as well. Okay, and this says that my x values are going to be greater than 5. All right, so I'm going to do this, come in here with red, parenthesis, we're going to be greater than 5. Okay, now let's do the other one where x is less than 10. I'm going to draw on my graph, put my 0, put my 5, put my 10. Okay, and so x is going to be less than 10. All right, so I'm going to put a parenthesis, and we're going to be smaller than 10, so I'm going to shade all the way over here. Okay, and that's that. Now, because we have a union, because we have a marriage, this one's going to put all their stuff in, and so is this. So they're going to have some overlapping items, overlapping parts of the graph. But let's come in, let's draw that in there. Okay, let me put a 0, a 5, and a 10. And what I want to look at is the fact that, they overlap. Okay, if we were to put them onto one graph, they would overlap, and that's what we want. It doesn't matter, we just want to plot all those points down. So every single part of this graph would be shaded in. And there would be no no like non-solution. Every solution will work. Okay? And so what I have here, if I wanted to put this in interval notation, I would say that this goes from negative infinity to positive infinity, and that would be, all real numbers. Okay? All right, so now let's take a look at the last one. All right, for part F, here's what this is going to look like. X is less than or equal to 1. All right, so if we draw this one out, I'm going to plot 0, I'm going to plot 1, I'm going to plot 4. And X is going to be less than or equal to 1. So we're going to put a bracket because it's equal to, and we're going to shade to the left. Okay? On the other one, X is greater than 4. Okay, we're going to have this. I'm going to plot my 0, my 1, and my 4. We're going to put a parenthesis here, and we're going to shade to the right. Now, since we're dealing with an AND situation, means the intersection, okay, my question is where do these graphs overlap? And the answer to that is that they don't. Okay, and so, these graphs don't interlap, all right? They don't have any intersection points, and so there are actually no places to shade, and we just put no solution. Okay? So what I've gone through here, guys, are all the different types of solutions that you can have. Okay? First off, these two are the same, okay? But then I just kind of showed you all the different scenarios that you could possibly run into when you're dealing with any of these problems, okay? So now what I'm going to do here is solve some compound inequalities and then graph them and put them in interval notation. So let's take a look at that. Let's take a look at part A. Now, what I've noticed here on this one is that negative 11 is larger than or equal to negative 3x plus 2 is larger than negative 20. So what I want to do is I want to isolate x in the middle of these two inequality symbols, okay? So these two. So what I'm going to do is I'm going to move the 2 out, okay? And so what I'm going to do for the first part is I would subtract 2 from both sides, or from this from the middle. If I do that to the middle, I'm also going to have to do it to the right side, and I'm going to have to do it to the left side. All right. So as a result, I'm going to get negative 13 is less than or equal to negative 3x, which is greater than or equal to negative 3x, which is greater than negative 22. Okay, now what I'm going to do is I'm going to divide everything by negative 3. Okay. Now, when I do that, both of these are going to turn positive. Okay. So I'm going to get positive 13 thirds. Okay. And I'm going to have to flip my inequality symbol. Okay, which is less than or equal to, just x, and then flip this inequality symbol, less than, and this is going to be 22 thirds, okay, because two negatives make a positive. So if I wanted to graph this, all right, I just come in here, I find 0, okay, 13 thirds is right here, all right, don't have to be very specific, and then 22 thirds is to the right of that. All right, and so then what I'm going to do is I'm going to shade in between. All right, I'm going to include 13 thirds, okay, and then I'm not going to include 22 thirds. All right, and that's my answer. Now, if I wanted to put this in interval notation, then all I would do is write 13 thirds, okay, bracket, comma, 22 thirds. All right, parenthesis, and that's it. All right, now let's take a look at part B. Part B says 5x minus 2 is less than or equal to 0, and 3x is greater than 1. So let's do the first one. Okay, And what I'm going to do first, let me rewrite it. So I got the colors right. I'm going to go ahead and add 2 to both sides. And then I get 5x is less than or equal to 2. So then I'm going to divide everything by 5. Now I don't have to switch my inequality because it's positive, and I'm going to have x is less than or equal to 2/5. Okay? So I've got that inequality. Okay, now let's do the other one over here. All right, do this one in blue. 3x is greater than 1. I'm just going to go ahead and divide both sides by 3. All right, and so I've got that x is greater than 1/3. All right, and that's my inequality. All right, so now I'm going to graph both of them. Okay, let me do the first one. All right, so let me do, I'm going to put a 0 here. And I've got x is less than 2/5. 2/5 is the same thing as 0.4. All right, so I'm going to plot that here at at 2/5. Okay, and then 1/3, that decimal is going to be 0.3 repeating. All right, so that's going to be a little bit to the left of that. It's going to be a little bit smaller than 0.4. All right, but I'm still going to put it there. All right, this is 1/3. All right, and I've got that x is less than or equal to 2/5. So I'm going to go in here, I'm going to shade this to the left because we're smaller than 2/5. Okay, if I graph the other one in blue, all right, let me put my numbers down, 0, 1/3, okay, and then 2/5. Okay, and if we're going to be greater than 1/3, we're going to have a parenthesis here and shade to the right. Now, we are dealing with a union. Okay, we're dealing with an and. All right, so we're going to include both of them. Where are they at? And so if I were to graph all this on a number line, all right, here we're going to have 0, here we're going to have 1/3, here we're going to have 2/5. Put this in a parenthesis, put this in a bracket, and we're going to shade in between. All right, so in interval notation, I'm going to write 1/3, comma, 2/5, bracket. Okay, make that look nice. Make it look like a bracket. All right, let's look at part C. Now this one is a union. Okay, so what I'm going to do on this one is I'm going to solve this one first. So I've got x plus 5 is less than -3. Okay, I'm going to go ahead and add 5 to both sides. And that's going to give me that x is less than 2. Okay, -3 plus 5 is 2. Okay, there's that inequality. The other one is x plus 5 is greater than or equal to 4. Okay, and so we're going to subtract the 5 from both sides. Okay, and so then we're going to get that x is going to be greater than -1, greater than or equal to -1. All right, so there's, let me graph both of them. Let me graph the red one. Okay, here's 0. Okay, here's -1. Here's 2. All right, and we're going to be less than 2. So less than, parenthesis, shade to the left. Okay, over here we're going to be x is greater than or equal to -1. So 0, -1, and 2. We're going to be greater than or equal to -1, so put that there, shade to the right. And we're going to be a union because it's or, okay? And so that's that's a, put everything in the same thing. So when we graph this, okay, put my 0, my 2, my -1. Because, these two graphs overlap, okay, my solution set is going to be all real numbers. I'm going to graph everything. Okay, and then in interval notation, I would write that as -infinity, +infinity. All right, let's take a look down here. Now, on these two examples, it's asking us about, for the given functions, use interval notation to write the domain of f. Now, for these two functions f, in the first one, I've got what's called a rational function. Okay, it's in fraction form. Okay, this one is a square root function. Okay, it's got a square root in it. So let's first look at part A. Okay, let me do that one first. So A has f of x equal to 2 over x minus 5. Now, because this function is in a fraction form, okay, what I know is that the denominator, okay, the denominator cannot be 0. So what I want to do, that's going to help me find my domain, okay? In this, what I want to do is I want to take my denominator, set it equal to 0, okay, and I'm going to add 5 to both sides. And I'm going to get that x is equal to positive 5. This is the value that makes my denominator 0. So because that's the case, my domain, okay, and remember that's where you have x values, would be all numbers, all real numbers, except x cannot equal 5. So every single number except for negative 5, okay? And what that would look like on a graph is this. Here's 0, here's 5. I could have every number that's smaller than 5, and I could have every number that's greater than 5. I just couldn't have 5 itself. So if I were to write this in interval notation, what I would write is I would say from negative infinity to 5, okay, union that from 5 to positive infinity, okay? And that's my answer in interval notation, okay? Now let's look at part B. And that function here would be f of x is equal to the square root of x plus 2. Now what I know about square roots is that whatever's underneath the square root symbol must be larger, must be larger than 0, must be 0 or larger. Okay, so whatever's underneath that, has to be greater than 0. So what I would do is I would do x plus 2 is greater than or equal to 0. I would subtract 2 from both sides, and this would give me x is greater than or equal to negative 2. Okay, to graph this isn't too bad. Okay, I'm going to put my 0 here, put my negative 2 here, and we're going to be at least at negative 2 and be in shade to the right. Okay, and so let's look at something else here. Let me graph both of these on Desmos and kind of take a look at them. So let's come over here. Let me paste this in up here to show you. And what I notice about this graph is that I have points. I have any point on this graph except when x is equal to negative 5. Okay, at positive 5. Okay, when x is equal to 5, I have this thing called a vertical asymptote. Okay, and so I don't have a value there. So all the values exist less than 5 or greater than 5. Okay, all right, let's talk about part B. Okay, and on this graph, what I notice is that points exist when you're at negative 2 or when you're bigger. Okay, and that's what I'm describing here. All right, in here. So kind of some cool stuff. There is a lot of stuff going on in this. I know this is a really long video. I didn't want to make it that long, but that's kind of what we're dealing with. So I hope you enjoyed this. Hope you learned something from each of these. Here's your homework for those sections, and holler if you got any questions. Thanks a lot. Bye.